Welcome to the GOA-ON webinar. We'll get started in just a minute to give people time to sign in. Thank you. Welcome to the GOA-ON webinar. We are now going to get started. I am going to talk you quickly through an introduction. So my name is Katharina Scholl. I am an Associate Project Officer for Ocean Acidification at the Intergovernmental Oceanographic Commission of UNESCO. And this webinar series, the GOA-ON webinar series, has 4 sponsoring organizations. First, GOA-ON, the Global Ocean Acidification Observing Network. Second, NOAA, the National Oceanic and Atmospheric Administration of the United States. Third, the IAEA OAICC, which stands for the International Atomic Energy Agency, Ocean Acidification International Coordination Center. And last but not least, the IOCCP, which is the Intergovernmental Oceanographic Commission of the United Nations Educational, Scientific, and Cultural Organization. For those of you who are new to GOA-ON, it is a collaborative international network of over 1,100 members from 110 countries, designed to detect and understand the drivers of ocean acidification and the resulting impacts on marine ecosystems. During this presentation, all participants are in listen-only mode. You're welcome to type any questions you might have into the questions box, which should appear at the bottom of your screen. And we will be monitoring these questions. We will be starting with a few questions after the first presentation and come back to all of the other big questions after the presentations. You're also welcome to raise your hand. There's a button at the toolbox at the bottom of your screen. And in that case, we can call on you directly and unmute you so that you can ask your questions directly. And with this, I'm hoping this is going to move. I would like to introduce you to our panelists. Hang on, next slide, please. Okay. I'd like to introduce you to our panelists and to our presenters. Give me just 1 second, please. Who are, first of all, oh, hang on, I'm sorry about this, slight technical issue here. Who are Maribel García-Ibáñez, I will come right back to you, and from the Spanish Institute of Ciencias del Mar, as well as Regina Easley from the National Institute of Standards and Technology, NIST of the United States. And today's moderator is Artur Palacz from the IOCCP. And with that, I would like to hand over to Artur. I'm hoping I can actually get out of this screen again. Apologies for this. Hang on. Sarah, can you briefly take over, please? Here we go. All right. With that, apologize. Artur, the floor is yours. Thank you.
Okay, thank you very much, Katerina. Thank you very much, GOA-ON. It is my great pleasure to be moderating this webinar today. I think it's going to be a great 1 or 2 hours where we can all collectively get an update on where we are with the global situation with the reference materials for the carbonate system in seawater. And today we're going to have 2 presentations, as Katerina said. And first up, we will have Maribel, who's working as a postdoc at the Institute de Ciencias del Mar, CSIC in Spain. And Maribel has been a member of the scientific steering group of the International Ocean Carbon Coordination Project, of which I'm a project officer for. And she has been responsible for this theme on ocean interior observations, but also really within IOCCP, driving forward these global discussions about coordination and communication related to design of a new and more resilient production model for reference materials for seawater carbonate system. Without further ado, I'm just going to hand over to Maribel.
Thank you, Artur. Let me start sharing my screen. Hopefully it works better than for Katerina this time. Let's see. Okay. So yeah, as Artur said, I am Maribel García-Ibáñez, and I work as a postdoc in Barcelona in Spain, but also I am part of the IOCCP steering committee. And we wanted to have this GOA-ON webinar to inform you on this effort that IOCCP is helping to coordinate globally to create a more resilient production and certification for reference materials for the seawater carbonate system. So let me check this works. Yeah, hopefully it moved. But before I start talking about this scheme of production and certification of seawater reference materials for the carbonate system, I wanted first to introduce why we need such reference materials. So the figure that I'm showing here is a pretty known one from the Global Carbon Project, where every year they update us about the role the oceans play in uptaking carbon dioxide from the atmosphere. And we know from these projects that the world's oceans take up around 25% of our annual CO2 emissions to the atmosphere. And this helps us slow down global warming. And to keep track of this uptake, we need to, to know this uptake helps us to understand climate change and determine what actions we need to take to achieve, for example, the objectives marked by the Paris Agreement. But how do we know how much CO2 is taken by the oceans? So to know this, scientists have established a global network to collect data that can be used to determine ocean CO2 uptake. And Regina will talk later about which measurements we undertake to do these estimates. But all these measurements of these networks require reference materials in order to achieve comparable measurements that allow us to assess these changes in the ocean carbon cycle and also to quantify trends in ocean acidification. Therefore, it is essential that we continue to assess the efficiency of the oceanic carbon sink through measurements of the best quality that need these reference materials to be comparable among laboratories and techniques. However, as most of you may know, the supply of reference materials for the seawater carbonate system relies on one single laboratory managed by Dr. Andrew Dixon at the Scripps Institution of Oceanography in the USA. But during the COVID pandemic, we saw how fragile was this current production system of seawater reference materials for the carbonate system, as this was stated in the Science News article published in September of 2021. And this dramatic reduction, if the supply of reference materials during the pandemic forced many groups to produce what commonly we know as secondary reference materials, but the proper terminology should be in-house or working reference materials. And Regina will also explain you a bit more about different terminologies of reference materials. And because there are no protocols to prepare these in-house reference materials, this resulted in non-uniform production and compliance measures and uncertainty estimates. So with that in mind, several targeted events and meetings focused on creating a robust, resilient, and global production network for seawater reference materials for the carbonate system. And one of them was organized by IOCCP in spring 2022. And in the remaining slides, I will present you the outputs of the discussions held during that meeting and the developments that have occurred since then. So the potential new model for the seawater reference materials for the carbonate system that was discussed is the one that is presented in this slide, that is centered on regional hubs, each one of them having their own production and certification centers. And as you see, you have on the top of the figure a transitional model, which will be helping to establish each of the hubs that currently don't have any production or certification center yet established, with the idea to have the model in the bottom, which says final new model, where each hub will have their production in separated for certification, and the later will happen in National Metrology Institutes or NMIs. And in this new network that we proposed during these meetings, it will involve the establishment of spaces capable of bottling and distributing seawater in this geographic strategic location. So with one hub, we remain in the United States, and then it will require the creation of at least 2 additional hubs, one in the Euro-African region and another in the Asia-Pacific region. And in this model, the regional hubs, the production part of them, could send their samples to a highly qualified laboratory. In the transitional model, this will be sent to, we propose this will be sent to NIST, the National Metrology Institute of the United States. And in the later states, it will be sent to a local NMI, and they will perform the certification of the materials. And the production hubs would be responsible for conducting the initial characterization of the material and likely to continue performing stability testing. And in order to ensure the quality of the hub's analytical capabilities, cross-validation inter-laboratory studies or quality assurance programs will need to be established. But what is the status of this envisaged new model of production of reference materials for the seawater carbonate system? So I will start with each hub separately. So in the US, Scripps will remain being the primary producer of these reference materials, and NIST is working on establishing the certification capabilities for total alkalinity and total dissolved inorganic carbon, or TA and DIC. We know that, for example, in Latin America, some laboratories such as the University of Baja California in Mexico have been producing this in-house or working reference materials for laboratories in Mexico. So taking this again up, as I was explaining before, many labs producing their own in-house reference materials. From the IOCCP, we also wanted to know what was the status of preparing standard operating procedures or SOPs for preparing these in-house standards or reference materials. And there are 2 proposals that are working on creating these SOPs. The first one is led by Dr. Andrew Dixon at Scripps and is funded by NOAA. And the second one is part of the European Research Infrastructure Euro-GOSIP, and the SOP preparation is led by Tobias Steinhoff at GeoMar. I wanted to highlight that regarding these working reference materials that are used to reduce the need of the reference materials coming nowadays from scripts. It is not enough to have the measurements of these in-house materials to ensure measurements that are comparable across different laboratories. It still need to use reference materials such as one produced at the scripts to be able to have comparable measurements among different laboratories. For the case of the Euro-African Hub, it kind of starts from scratch in terms of connecting the oceanographers with the National Metrology Institutes, but we can use different platforms or organizations to enhance this connection between oceanographers and NMIs. So for example, we have EURAMET, which is the European Association of National Metrology Institutes, which in 2014 established the European Metrology Network for Climate and Ocean Observations to improve, among other goals, the quality of essential ocean variables by increasing the linkages to the international system of units and improving measurements accuracy. And I think Regina will also explain you a bit more what are these essential ocean variables that I'm talking about here. We also have two European projects, MINCE and SAFTICE, that in which there is collaboration between oceanographic institutions and NMIs that are focused on working on the seawater system, of the seawater carbonate system. But in this case, they started with the pH indicator dyes, but these projects could help us to start the connection between NMIs and oceanographic institutions for the Euro-African Hub. And we also know that two NMIs, PTV in Germany and LNE in France, are searching measurement services related to the seawater carbonate system measurement. So there is a room for creating this Euro-African Hub here. And in Africa, we know that they have their monitoring programs, which require high amounts of reference materials, and will be happy to also host local production center in South Africa. And finally, for the Asia-Pacific Hub, we know that both Japan and China are producing in-house or working reference materials, all based on the production of scripts reference materials, and their values are assigned also based on the values of the scripts reference materials. So again, they are depending on the supply of the United States, but they have the capability to at least provide for their own countries. In the case of New Zealand and Pacific Islands, they only have technical ability to prepare regional in-house or working reference materials, not to establish a hub there. So what are the advantages for the proposed model of production and certification of reference materials that we have discussed until now? So the first of them is the reduction of the cost for the users, because most of the cost from the reference materials comes from shipping, as the seawater comes in glass bottles, borosilicate bottles that represent 40% of the weight of the reference materials, making it cheaper if they are supplied from a local producer more than if it comes across the globe. The second one is that the new hubs will be able to prepare the reference materials from seawater taken from different ocean basins. So from those unfamiliar with the current seawater reference materials for the carbonate system, they are produced using Pacific seawater. But these reference materials are used to ensure measurement accuracy on seawater samples, not only from the Pacific, but from the global ocean, which presents a wider range of DIC and TA values, as you can see in the figure. You can see the average properties in the different ocean basins above and below 500 meters depth, and also the average properties of the reference materials and the standard deviation with the red lines. And you can see that in the case, for example, of the high salinity and high alkalinity Mediterranean waters, the seawater carbonate system properties vary from the reference materials ones by more than 100 times the uncertainty of the measurements. So the mismatch of the properties of the seawater reference materials for the carbonate system and the seawater samples analyzed can pose some issues, especially for laboratories that use the seawater reference materials to calibrate their equipment due to the lack of other calibration techniques. We know that this should not be used this way, but we also know that many laboratories use the reference materials to calibrate their equipment. Therefore, having multiple reference material compositions will increase the measurement accuracy of those groups by providing more than 1 point to confirm their calibrations. And finally, and Regina also will talk a bit more about this, the new model of production certification of the seawater reference materials will be integrated into the global metrology system. But this will require unprecedented involvement of National Metrology Institutes on a global level. But it will come with the advantage that integrating this new model into the global metrology landscape will help to produce reference materials that are comparable and metrologically traceable to the international system of units. And the National Metrology Institutes could also expand the properties certified in the reference materials into other properties, such, for example, isotopes. And as I said, Regina, my colleague, will present the developments of from the perspective of a National Metrology Institute, NIST in the US, in the following presentation. And before I let the floor to Regina, I wanted to highlight again how important these reference materials are for knowing how much carbon is stored in the oceans. So as maybe some of you have already seen this paper, it's from the 90s, and they already highlighted the need of reference materials to calibrate and validate measurements to be able to detect the long-term climatic changes, such as the increase in anthropogenic carbon in the ocean. So in the figure on the right, that is from that paper, they show how the increase in DIC that is expected from an increase in anthropogenic carbon between the 1970s and the 1990s was undetectable due to the non-existence of reference materials in the 1970s, and even though the laboratories were very capable of doing the measurements. Therefore, these reference materials are crucial for monitoring the efficiency of the oceanic carbon and ocean acidification signals. And before I finish, I just also wanted to highlight that because of this importance of having comparable measurements in all the laboratories across the globe, this is why the production and certification of seawater reference materials for the carbonate system should be included as a priority in global programs, such as the recently approved WMO Global Greenhouse Gas Monitoring Infrastructure. And in this infrastructure, there is no mention of the need of reference material, and they are crucial for the proposed ocean carbon cycle observations. And we also wanted to use this webinar to inform people that may have not been involved in this discussion and may be able to help us to push forward this new scheme. And to inform you as well that we are starting to draft a position paper highlighting the need of these reference materials that can be used to ask for funding to establish the proposed regional hubs. So we want to invite you experts that are already engaged or want to engage in developing the regional hubs to join us to write such position paper. And with this talk, we also want to highlight the need to maintain a certain level of coordination about all the initiatives related to the development of such production and certification model to avoid duplicating efforts. So we will be really happy if you could inform us if you have other developments in your countries that we are not aware of that could help to establish the the newest scheme for production and certification of the reference materials for seawater carbonate system measurements. With this, I have finished, and I'm more than happy to take some questions before Regina's presentation.
So thank you very much, Maribel, for this very comprehensive presentation. I noticed that questions are starting to trickle in, but I think I'll ask for your patience because the way we designed the webinar is that Regina and Maribel's presentations are very complementary to each other. So maybe it's going to be looking at the questions. I think it might benefit us if we just hold on to the longer question and answer session after Regina's talk. So please, if you already have some questions to the first presentation, please don't hesitate to type them into the question and answer. And in the meantime, I'd like to introduce Regina Easley, who's working as a research chemist at the National Institute of Standards and Technology in Maryland, United States. In her role as a research chemist, Regina co-manages also electroanalytical chemistry laboratory responsible for the production of pH standard reference materials. She is focusing on establishing this new NIST program related to the carbonate system parameters, as Maribel already indicated. And I really look forward to also hearing your perspective, Regina, on these global plans, the perspectives from a National Metrology Institute. So please, Regina, the floor is yours.
Thank you, Artur, and I'd like to thank GOA-ON for this opportunity. I'm really happy to be here. Let me share my screen with you all. Okay, does that work?
Yes, we can see it. Take it away.
Okay, wonderful. So today I'm going to talk about the development of NIST measurement services for the inorganic carbon system of seawater. And so this presentation is a result of the efforts of several staff members at NIST, including myself, Jason Waters, Michael Fong, Rebecca Kraft, Kim Harris, Jennifer Carney, and Mike Winchester. So as Maribel alluded to, essential ocean variables were identified by a panel of experts organized by the Global Ocean Carbon Observing System. And these are variables that need to be measured to determine ocean health and to forecast particularly issues related to climate change. These include biogeochemical measurements of parameters such as oxygen, nutrients, particulate matter, stable carbon isotopes, and inorganic carbon. Inorganic carbon is actually made of 4 subvariables that are shown here. So we have dissolved inorganic carbon, which is the total of CO2 star, which is dissolved CO2, and a little bit of carbonic acid, bicarbonate, and then carbonate ion. Total alkalinity is measured through titration, and it gives an idea about the buffering capacity or the ability of a water sample to withstand changes in pH. Fugacity of CO2 is really helpful for looking at air-sea gas exchanges. And then pH is the negative log of the hydrogen activity in seawater. And so by measuring any 2 of these parameters, you can calculate the entire system. And one important thing to note is that in order for us to actually assess climate change, pH and all of these carbon system variables are known as indicators of how climate change is affecting ocean chemistry. So around the early 1990s, there were 2 reports that came out that raised concerns about the need for seawater carbon reference materials. One of those meetings took place in La Jolla in 1986, and this was organized by the Committee on Climatic Changes in the Ocean. And another, which is actually shown here, was organized by UNESCO in 1988. The committee members included people like Andrew Dixon. This group organized an interlaboratory study where various labs conducted measurements of the carbon system parameters on batches of IOCCP standard seawater, and they conducted the study at different salinities. And so here I actually have the results shown for salinities 29 and 35. And you can see that where the mean values actually fall for these measurements, and the standard deviation is somewhere around plus or minus 30 micromoles per kilogram. If we were to kind of overlap this with the standard deviations that were obtained from Bachman and Dixon in 2015, we can see that actually having access to reference materials greatly improves the community comparability. In terms of reference materials for seawater, total alkalinity and dissolved inorganic carbon is standardized using the reference materials provided by Andrew Dixon's lab. pH is often standardized using tris buffer that's prepared in a synthetic seawater solution. People will also use purified metacresol purple, and some will use, if they're using glass electrodes, NBS buffers to look at the slope of their electrodes, and then they'll use the tris buffers in order to determine the liquid junction potential effect on the electrodes. PCO2 is standardized using gas mixtures from gas cylinders. And so I just wanted to highlight this to show that the two parameters, TA and DIC, are using the same reference material. This material is supplied by the Dixon lab. The first batch was distributed in January of 1990, and it provided values for dissolved inorganic carbon. Total alkalinity was added to batch 33 in 1996. And the latest batch, as you'll notice, it has values for total dissolved inorganic carbon and total alkalinity, was bottled in January of this year. And so these materials are basically what all of our ocean carbon measurements are traceable back to. In terms of distribution, I just wanted to highlight just the global need for these materials. Over the course of about 20 years, this figure is actually taken from a talk given by Dr. Dixon on seawater CO2 reference materials. And basically over 134,000 bottles have been shipped to 62 countries. If we just look within the US, we'll notice that 31% of the total bottles were shipped just within the US, and the highest users of these materials here are in California, Washington, and Florida. And so in projecting the needs of the global community for this materials, back in, I believe it was 2020, the Interagency Working Group on Ocean Acidification issued a survey where over 247 individuals participated. And they basically indicated that in terms of projecting their future needs for this material, well over half of the labs will either maintain their levels of use or they anticipate increasing their levels of use. And so this is why this new model that we are proposing is critical for this community. The Scripps program has been highly successful, as you note. It is the international standard for seawater CO2. In 2019, 11,000 bottles were produced, but some of the challenges, as Maribel stated, is that the pandemic halted production, and then there have been supply chain challenges, such as getting the glass bottles that are needed to house the seawater. In addition, they do have equipment that is aging, and we know that both the PI and the lead technician are nearing retirement. So what I'm going to talk about in this presentation is our transition to this transitional model where production will remain at Scripps, and then NIST is actually working to build our certification capabilities so that we can help, or we can actually provide values for dissolved inorganic carbon and total alkalinity. The other update that I will give today is that we recently learned that NOAA AOML which is located out of Miami, Florida. They are actually beginning the process to make small batches of seawater reference material. This is pretty critical because, as you remember from the US map, Florida is one of the larger consumers of these materials. So they will produce smaller batches at 200 bottles per batch. I think Andrew's lab produces about 1,200 bottles per batch. The contacts are listed here. They include Rick Wanikoff, Leticia Barbaro, and then Caitlin Shockman. At NIST, we have a team assembled to work on the certification of total alkalinity and dissolved inorganic carbon. This includes three oceanographers really that are on staff. So myself, Jason Waters, and Michael Fong. We are all part of the Materials Measurement Lab, Chemical Sciences Division, Inorganic Metrology Group. And we also are joined by Rebecca Kraft, who works on isotope ratio mass spectrometry, Kimberly Harris, who specializes in gas sensing metrology. Our gas sensing metrology group has developed substantial capabilities for determining CO2 and gas standards, and they support 13 standard reference materials for CO2 and air and nitrogen balance. And so with that knowledge, she will help us with the dissolved inorganic carbon. Another member of our team is Jo Wu, who is within our fabrication technology office, but she is our NIST glass blower who will help us to construct the vacuum line that is needed to do dissolved inorganic carbon. Just to give you an idea of how these certifications are done, as we are building our ability to look at total alkalinity, the process that we'll use will actually be based on the process that's outlined by Dixon in a 2003 marine chemistry article. This utilizes methods that were developed out of the National Bureau of Standards for the coulometric determination of acids and bases. So total alkalinity is determined by titration of a seawater sample to a pH equivalence point, which falls between 3.5 to 3. The titration is done with coulometrically standardized titrant, and we are proficient in the coulometric methods because we use these to certify several standard reference materials. We are in the process of purchasing a titration system that will be dedicated to the seawater total alkalinity measurements. Dissolved inorganic carbon is a little bit more of a challenge because we have to translate the expertise in CO2 and air analysis to seawater. And so in order to do this, and what is done by the Dixon lab is that to quantify total dissolved inorganic carbon, remember it's the sum of CO2 star, bicarbonate, and carbonate ion. To do this, a pipette is filled with a known mass of seawater, and this pipette is then it's weighed, phosphoric acid is added, and what that does is it helps to evolve the CO2. It converts all of those various forms of inorganic carbon dioxide into CO2 gas. Using a vacuum extraction system, they are able to trap out and to separate water vapor from CO2 using a series of sublimation steps. And so what we do not have right now is this actual vacuum extraction system. After the sample of CO2 is actually purified, the carbon dioxide is actually collected in flame-off tubes, and the amount of CO2 that's within that sample is measured by manometry. So the other challenge is that not only do we not have a vacuum extraction line, but we also do not have a manometric system to measure this CO2 gas. So what we have actually done over the course of the last, I would say, 6 months is we are trying to determine the best approaches that will allow us to provide values for dissolved inorganic carbon in a time-efficient manner. And so we went on several tours of labs. In January of this year, I had the opportunity to go to San Diego and tour Dr. Dixon's lab. I was able to see his seawater bottling facility, and I spoke with Guy, his lead technician, about the process of doing the DIC certification. And so actually since that meeting, we've had another follow-up to learn more about the intricacies of this vacuum extraction system. Also in January, we took a trip to the University of Delaware, and we looked at Wai-Jun Tai's lab, where they are able to do total CO2 measurements, but they're measuring it with a Picaro. The reason we were interested in this is that we know that using cavity ring down, we can actually look at not only total CO2, but also isotopes, stable isotopes of carbon dioxide. We were interested in this because we do have access to this type of instrumentation as well. And then in February of this year, we had a meeting with Stephen Meyer, who is a NIST staff member that actually helped to build the CO2 manometric system that is now housed at the International Bureau of Weights and Measures. And so we learned about this system. And in terms of the intricacies of this, what we realized is that we are a little bit concerned about the fact that this is made of stainless steel, because we know that carbon dioxide will absorb onto stainless steel. And so right now we're in the process of, we're deciding our approach, and we have come to the conclusion that in order to quantify the CO2 that's coming off of the vacuum extraction system, we will likely start our measurements using gas chromatography with a flame ionization detection with methanation of the CO2. The other aspect that we talked about, especially with Rebecca and Kimberly's involvement, is that in this process, we are hoping that, you know, after we have mastered the total dissolved inorganic carbon measurements, that we will actually be able to provide values for carbon isotopes, especially for the delta C13. So this is an added value that we are looking into. We have a isotope ratio mass spectrometer, which is purchased but not installed. But we're hoping that after that instrument is installed, we will be able to use this as well to generate delta C13 values on these the standards. So in terms of our timeline, this is a tentative timeline that takes us from the second half of this year all the way through 2026. Right now, what we are working on is purchasing the total alkalinity system. And we are also working with Joe to estimate the cost and the time that is required to construct the vacuum extraction line. In terms of planning, additional planning, what we know is that sometime next year, likely, we will also need to visit Scripps to have additional hands-on training of the method, because it's, you know, it's easy to kind of talk about the concepts, but I think it's just much better if our analysts can go there and actually see how the, especially the dissolved inorganic carbon, how are those measurements actually performed? We estimate that by the time we develop our methods, I would say around 2025, 2026, early 26, we will be able to develop a measurement service cost structure. So these measurements will likely be available for purchase. And right now we just need to figure out just the time and the cost of consumables that are needed in order to perform each one of the measurements for total alkalinity and dissolved inorganic carbon. In terms of total alkalinity, since this method has basically been developed by the Dixon lab, after receiving the equipment, we will do initial instrument testing, which will take maybe about 6 months. These are conservative estimates. And then we will perform a method verification just to show that our methods are comparable to Andrew's. what we have in store is that we will do some comparisons with SIO. So we can do direct comparisons of our ability to standardize hydrochloric acid, and then we'll do multiple comparisons on total alkalinity for new batches of seawater, just to ensure that the measurement qualities are similar. After this verification is performed, we will work on developing a total uncertainty budget for this measurement. With total dissolved inorganic carbon, the plan is to just move forward with the vacuum line fabrication, and that will start with fabricating a system so that we can introduce the flame off tube into our measurement device, which right now it does seem like it's GC. We will then work on the vacuum extraction line. For Kimberly, the first step in her process is, so what you're doing is you're purifying a sample of CO2. That sample is concentrated. One of the challenges in introducing that sample to the GC is it actually has to be gravimetrically diluted in order to optimize the signal for the GC. And so the first part of the method validation will involve the gravimetric dilution that is needed for that CO2 sample. Andrew has graciously offered to allow us to do comparisons between our measurements and his, because he has archived samples of the pure CO2. So we should be able to do some comparisons with his lab on some of those archived samples and maybe some of the new batches that are produced. So that will be our first point of comparison between his lab and our lab. And then Kimberly will go on to, and Rebecca will work together to extract the CO2 out of a seawater sample. And we'll have to do comparisons to look at the extraction efficiency and then just comparative measurements of total dissolved inorganic carbon using these different approaches, which are the manometric method for Scripps and then our method using GC. We anticipate that maybe by 2026, the isotope ratio mass spec may be online, and notice that these are ambitious estimates for that set of measurements, but we are hoping that maybe around that time we can look at some of the isotope ratio methods for total CO2. So as we are moving forward, one thing that we want to note is that we're really trying to be careful with our language and in the process, like differentiating between reference materials and certified reference materials. The term reference materials is a wide definition according to the International Vocabulary of Metrology, and it simply means that it's a material which is homogeneous and stable with respect to selected properties. On the other hand, certified reference materials or materials with certified values is more strictly defined. And so in order to have a certified value, if you are a primary certified reference material or a primary measurement standard, those values are obtained using primary reference measurement procedures. There are only a few procedures that actually qualify for that characterization. So for example, coulometry, gravimetry, and freezing point depression. And so for us, if we are to obtain a certified value on a material, in lieu of not having one of those measurements, we typically will combine two different sources or two different approaches to create a certified value. So what we're hoping is that using the GC FID methanation method, and then once we get the isotope ratio method on board, we can use those two values to approach creating a certified value for dissolved inorganic carbon. So in moving forward, this is what we are proposing. And this is actually just Maribel and I came up with this schematic of, how do we think about the language of certified reference materials versus reference materials? And so those materials that are certified at the NMI level can be used by regional hubs to produce their reference materials. In addition to the DIC and total alkalinity, we are still working on reference material 8083. We have a candidate material of purified metacresol purple, and we are standardizing this using buffers that have been measured with Harnett cell, and then the visible spectrum is characterized to provide the equation for this particular batch. We have measurements of the homogeneity of this batch, and that will get added into the overall uncertainty budget of this material. And so the other update that I have is within the CCQM electrochemical analysis working group, there was recently the formation of a seawater pH task group. And so the task group is entitled The Establishment of Metrological Traceability for Seawater pH and pH-T Values. It'll actually be active between May of this year and April 2026. And so there's a 3-year time frame that this group will be operating. Jason Waters from NIST was nominated as chair, and Raquel Quindera of IPQ, which is the Portuguese NMI, was nominated as deputy chair. The group will actually seek help from external experts, and we're looking for input from the community. And that will include members of people that are involved in global ocean observing systems, ones that are involved in groups that are looking at ocean uncertainty quantification, and even GOA-ON. So definitely look this group up. And there will be I think a web space for this on the BIPM website. And like I said, Jason Waters was nominated as the chair of the group. And as for our efforts at NIST, we do have a NIST Ocean Carbon page. And so you can look here to also see updates on the work that we're doing. And so I thank you for your time, and I look forward to any questions that you have.
Thank you very much, Regina, for this really comprehensive presentation, walking us through the current progress at NIST, but also the plans for the future and challenges associated with, taking over and expanding on the services provided by the Dixon's Lab for the community for so long. We have a number of questions in the chat. I'm going to take the liberty of grouping them a little bit. And I want to start with something that is related to Maribel's presentation first, which is about the importance of reference materials at the different extremes of the range of the salinity levels. So Maribel, you've shown that the graph, the slide, showing the example of the specificity of the Mediterranean waters and how the current source waters for the CRMs are perhaps not adequate enough for the measurements in that basin. And we have a number of questions from Luisa Genudi, but also Caroline Fradet asking about suitability of reference materials for work with salinity over 35. But also Valentina Amaral and Cesar Bernal are asking about possibilities of making reference materials more suitable for working in the coastal systems with salinities lower than 30 or even 20. So if you could share any thoughts on that, that would be great. Thank you.
Yeah, this was also part of the discussion when we were in the meeting in the spring last year, how broad we can make the reference materials. So what I presented was kind of the initial state to have kind of one representative reference material per basin to start with that. But we also discussed on having high salinity or low salinity reference materials. In the case of high salinity, and hopefully I'm saying this correctly, and if not, Regina can correct me, I don't see any issue with certifying values for high salinity waters if they are open ocean waters. But the question from Cesar that he was asking about coastal system, and there was also some discussion during the spring meeting last year about Baltic reference materials, for example, as well, and they have extra challenges in the way that they have high amounts of organic matter, and that may generate issues in terms of stability of the material. So it needs extra care for coastal or high organic matter content waters in making sure that the materials are stable and homogeneous. But I think the kind of main constraint of having different say compositions of reference materials is where the water can be supplied, or where the bottling facility is decided to be placed. I think that's where the waters may come from most likely. So if, for example, there is a bottling facility in the Mediterranean Sea, and that is in the high salinity region, there will be a high salinity reference material provided. If not, that will be maybe not possible in the near future. What was also discussed was maybe using opportunistic cruises, for example, Eurofleets or other opportunistic cruises where large batches of water can be taken to be supplied to these bottling facilities in order to have like more variety of supplies. But that is all kind of ideas that are up in the air, and the final kind of solution is still in terms of discussion. But we are aware that a lot of carbon research is performed nowadays in coastal waters, and also for marine carbon dioxide removal purposes, it will be great to have them as well from coastal water. So we know the need, but this is just kind of this presentation was just to introduce what is discussed, and when maybe the hubs are established, that we can ask them to have a variety of compositions, if that's possible. And I hope I answered the question, all the questions related to different salinities in the chat.
Thank you very much, Maribel. Regina, is there anything you would like to add about this one? Or?
The only other thing I would say, or at least one of my concerns, would also be like, when you change the composition, especially as you're moving closer to coastal waters, is what does that do to the stability of the material due to the the properties that you're trying to provide values for. So I think, as we're moving forward, that's something else that we'll have to just take care in looking at.
Okay, thank you very much. Next question, it's going to be Regina, to you, and it comes from, oh wait, it disappeared on my screen now. Oh, here it is. It's from Stefan Zeitz. It's about whether you could provide a list of all measurement quantities that require reference materials. Is it just, total alkalinity, DIC, pH, PCO2, or any others? And I'll maybe follow up and expand on this question a little bit, because you showed in your slides sort of the timeline of the operations and the developments at NIST, starting with TA and then ending with some prospects for reference materials for pH. So how important is it that as we try and design these regional hubs, that we consider all four of these variables at the same time in terms of reference material development? Thank you.
I think it's critical to have values for or reference materials for all of them, because people are, making measurements, and we want to ensure the quality of those measurements. So we definitely need them, of course, for DIC and total alkalinity. Those are probably the two parameters that are most measured aside from pH. And I'm sure Stefan is aware, like that's the reason that we have the task group now at the EAWG, is that we're looking at the traceability of those pH measurements. And the other thing I would say is that, like, for something like PCO2, I think that the technology is evolving now that more labs can have access to this measurement. So we really kind of, I think, not only need to look at having reference materials available, but also looking at some of our practices. Like, are we using the same materials for standardizing the measurements as we are using for quality control? And how can we have just materials that are available for labs to affordably ensure the quality? In terms of some of the other essential ocean variables, I think that, you know, particularly things like oxygen are things that we also need to look into. But I don't know if you want to expand at all, Artur, on that.
Yes, thank you very much, Regina. We certainly already have also a history of nutrients in seawater and reference materials for them, right? I don't know, Maribel, anything else you would like to add on this particular point?
No, I think Regina explained well, because this seminar was mostly focused on the carbonate system measurements. So of course, there are many more reference materials that we need for the essential ocean variables, but we are not maybe the experts of those.
And the other thing I'll say, like in terms of the isotopes, is that right now, I don't think that there is actually a standard, like a matrix-based standard that's available for like delta C13. So that's why in our process, we really want to press to have those values available.
Thank you. And I'll just forward a comment from Cesar Bernal that Quasimem is offering an interlaboratory with salinity between 7 and 9, and it would be good to review these results in terms of stability, measurement, dispersion, and review the organic matter load that they handle in the sample. So maybe that's a useful piece of information corresponding to our discussion. Okay, I would like to move on to a few other questions that have to do maybe with the technicalities of development of the reference materials. And I'll start off with a general question from Andrew Dixon that I can follow up with a few others about specific means of maybe improving the production methodology as we move forward. So Andrew is asking, saying that the system you described builds on the current US developed approach, and what is the additional research that will be needed to improve the production methodology moving forward? So please, both of you, if you have any comments on that.
I think Regina maybe have some thoughts of the metrology labs that I think are the ones that can help us with this.
Yeah, I think in terms of production, definitely two things that we've talked about, and I know that we've talked about this extensively in the ocean carbon system intercomparison forum, OCCP group, is that we could improve the like the packaging to make it cheaper to ship the materials, and also maybe looking at different preservation methods. Instead of adding, right now, mercury is added to preserve the seawater sample. So I know that those are factors that some labs are looking at. But I think having the capability of measuring a parameter, for example, total alkalinity, like really well, it'll help you to gauge like how stable is the batch that you're producing, and are you able to distinguish between preservation methods. So for us, we'd actually, I think, be interested in testing out different ways of preserving the samples, but we would have to do this after we get our alkalinity system set up. And I don't know if you have anything additional to add. Oh, I would say the other piece that we are looking at is like as we're developing our methods, we will try to, we'll definitely have an uncertainty budget, but we'll also try to get budgets that are kind of compliant with the guide to uncertainty in measurements as we're doing that, because having a certified value on a material also requires that you have a full uncertainty budget. So we'll need that in order to get a certified value.
So if, yeah, regarding to what Regina mentioned on the packaging and preservation, there are also a few questions on the Q&A about that. And we also discussed about this in the spring's meeting. So there is still room for research on how stable are materials that are packaged in, for example, disposable, maybe plastic containers that are not as heavy as the bottles that are used nowadays, and the preservation methods. So for both kind of research areas, we are aware that Japan are trying to produce these reference materials in the same containers that are used for sodas, the metallic ones, and they also autoclave the water to preserve it. That is kind of an alternative, but it takes a lot of time and it's really expensive as well. And it may not be the perfect alternative, but there is already some research going on these two fields. And as Regina said, we need more research on that, making it the material less heavy to ship, and then able to be shipped worldwide because it doesn't have mercury chloride added on it. And also there was a question from Valeria Ibelo about the effect of the changes in total alkalinity and DIC in the bottles, and how other bottles can maybe avoid these issues. So definitely in these new hubs and in the future work, this needs to be all taken into account. What we try to present here is how we can start with what we know nowadays. That is what the US is doing, but for sure improve what is there, and not kind of close our mind around this current production of and certification that we have. Well, we don't have certification to say so, but yeah, the as value assignment that we have. And I remember if the VIP in the VIPM workshop that we had not that far away, that there was some discussion of how maybe also if we have more National Metrology Institutes engaging in the certification of the values, maybe different methodologies can also be developed to certify the measurements, so we have a better idea that the values that we are certifying are closer to the true value over there. So there is plenty of research to be done in the new scheme. So that's why we need a lot of people to be putting their heads together to improve this.
Thank you very much to both of you. Maybe perhaps also related to development of production methods. There's a question from Anthony Lucio. Do you think electrochemistry could play a larger role in the generation of reference materials? Maybe Regina? Or?
Okay, I think that's a good question. I do know that within the electrochemical analysis working group at the BIPM, recently there was a pilot study actually that was done on artificial seawater buffers with pH. And so they were looking at some of the intricacies of measuring electrochemically the pH of those buffers. And I definitely think that with the new task group that as electrochemists, they'll be able to kind of highlight some of the areas that we can possibly make these measurements more traceable to the SI. So I definitely think that there is a lot of room for electrochemistry to help make these reference materials more available. I hope that answers your question. That was just one example that I could think of.
Thank you very much. I would like to go back now to something we discussed just a few minutes ago about the alternatives for bottles and packaging. And a little bit take out what Valeria Ibel also asked in the question about the cost benefit of using a different bottle than a glass one. Also related to that is a question from Dwight Gledhill, who says that most of the cost is actually not shipping, but in staff time for the production. And he's asking if the new production centers will truly yield cost savings when you factor in the full cost of production. Note that the production costs are subsidized in the US by the National Science Foundation, which is a cost savings passed along to international recipients. So will these production centers be similarly subsidized by their host nations? Maribel, would you like to maybe take a stab at this one? Very much related to the practicalities of cost benefit analysis here. Thank you.
So we also discussed this, and also there are other questions related to the fact of this subsidizing, and maybe make this reference materials more accessible for laboratories that don't have much income for their measurements. So there is the idea with this creation was to also have this subsidized bit, but of course we all depend on which institutions are funding the production of the new hubs. So far we don't have more funders than what we have in the US, but we will be more than happy that the new hubs funders have in mind that not everyone can pay maybe 200 euros per bottle if the staff part is not subsidized, and they understand the importance of having these reference materials available for all the countries. But as IOCCP, we don't have any power to subsidize the reference materials. And I don't know if you, Artur, want to say anything else.
Yes, thank you very much, Maribel. Of course, this is it's going to be a big issue that needs to be settled in the future. And like you say, it's something that we need to take into account while designing this. And this and other aspects are one of the main reasons why we would like to have these broad community consultations about these ideas, to gather your feedback, but also expose these plans to a broad range of stakeholders who we are very happy to see are present during this webinar. Maybe very following up on that question, I want to call the question from Richard Sanders about whether you have a feeling of what the scale of the bottling and production operation is likely to be, both financially and in terms of space and people. And is there a plan to transfer the know-how around production to other new hubs? So, I think as Regina has shown in the presentation, they are already going through this step right now, and probably being able to say something a little bit about the cost of doing this, which of course would need to be adapted as we think about this in other regions and stuff. But please, Regina and Maribel, if you have any comments on Richard's question. Thank you.
Yeah, Regina, please go ahead if you have any.
Okay.
Sorry.
Yeah, so I mean, I feel like one thing, because I think it was alluded to in the IWGOA survey, is that, various regions have needs for different quantities of the reference material. And so I think that, approaching it, like looking at what is the demand in that region would be a helpful way to move forward. I noted that AOML is starting with batches of 200 bottles. And I feel like, for their operation, that is probably is quite manageable. I don't know, how the price structure will end up, like how much time is dedicated for that personnel to do the bottling and then to provide values for the materials. But I think, when we're looking at these regions, that's something that we just need to consider, is just what is the current consumption and what are the projected future consumptions, and what space is available at the various production centers to actually bottle the material. I know, like at NIST, we do more pure water standards. And I think we have the ability to produce about 5,000 bottles at once, but these are much smaller quantities. I think the other thing that we have to consider is the fact that right now, the standard is a 500 milliliter volume. So perhaps if the new hubs are being set up and if they're using different equipment and maybe even different packaging, you might actually be able to produce more bottles because they are smaller quantities. So as we are moving forward, I think it will be really important for us to coordinate these efforts and really just, learn lessons from each other as we are developing the capabilities. I don't know if you have anything else that you'd like to add, Maribel.
I was just looking for a slide from Andrew's presentation when he presented how his lab managed to prepare the reference materials that we all use. And just to give an idea of what Scripps has to prepare the batches that they supply. So they use around 720 liters per batch. So you have to account that in mind if you want to prepare as much as they do. They have, I think this is in square feet, if I don't remember wrong, I think it was around almost 400 square meters. So over 4,000 square feet for the space that is used to prepare the reference materials. And then they have the chemical laboratory as well. They have all the specialized equipment, including bottles and the products that are used to clean the bottles, fill the bottles and all that. They have 3 full-time staff working only on that, and then 1 person working on billing. And there is also a question from it is Thorsten asking about how much NSF is subsidizing this, and it was also in the slide. So in 2019, the budget was $200,000 from the National Science Foundation, and they recover $330,000 from the bottles that are returned to the labs, but also with that in mind that the university is giving the staff and the space that they are not paying for. So that's kind of an idea of how much it costs to have Scripps facilities.
Thank you very much, both. I would like to move now to a series of questions related to standard operating protocols, related to these in-house reference materials. I think this is a very important issue that we need to consider and also clarify. You've mentioned, Maribel, in your presentation that both Andrew and Tobias are working on SOPs for reference materials. There's a number of questions here in the Q&A asking about the need for developing these and how accessible these would be to those who are, I presume, have interest in developing their own in-house materials. So I'll just start with that question. Maribel, maybe you could take this one first.
Yeah, so we had a meeting a few months ago with both Andrew and Tobias about this. So the SOPs prepared by that are starting to be prepared by Andrew are mainly for NOAA laboratories for the starting with, and maybe after the entire process is finished to test that the SOP works, that the labs, NOAA labs can produce and achieve the same results as Scripps does. I don't want to talk in the name of Andrew, but maybe that can be shared after the process. But originally, this is funded by NOAA for NOAA labs. And in terms of the EuroGO-ship proposal, I haven't heard from Tobias that they are not happy to distribute these SOPs broadly, because basically this is part of these research infrastructures that wants to improve measurements in Europe. And being part of GOA-ONShip, I assume they will be distributed as well outside of Europe. But all this should be clarified by both Andrew and Tobias, because I don't want to say they will be distributed and that's not plans for that.
Maybe if I could follow up also with a question related to Kim Curry's, that you know, of course, producing this type of reference materials, the in-house ones will be cheaper, but they will also have a larger uncertainty. So you know, presumably that these SOPs will not be distributed and available broadly anytime soon. How do we tackle and address this potential risk of reducing the quality of some of the measurements, which are, you know, feeding our climate models and climate assessments?
Well, I think even though we don't have SOPs for preparing the in-house, we do have SOPs to make sure that we are measuring what we are measuring in the seawater carbonate system. So at least if we are sure that our systems are calibrated correctly and we have a handle of at least one reference materials now and then to control that we are doing great, that's how I see that we can do so far. But I don't know if Regina or you, Artur, have other ideas of how can we manage until we have all this ready.
Right. What I would say is that, you know, definitely just take care of how you use, especially the valuable reference materials from the Dixon lab. And I think having in-house materials can at least help you gauge your just the quality control of your system. With quality control materials, the really important thing is that sometimes it's not even that you know accurately what the value is, but you know how to assess whether or not that material is stable over time, because you're just looking at the changes of that over time to detect if you have any type of drift in your system. And so just like Maribel said, I think, you know, having access to a reference material and just really using those standard methods that are available is probably the more critical part. And I do think that, you know, moving forward, we definitely need to have more, I think it's helpful to have more interlaboratory comparisons for this community, just to ensure that we are all capable of making the measurements and to detect if we have any measurement challenges.
Thank you very much. And Regina, you have just moved swiftly into the next question about intercomparisons. And again, there's a couple of those here, but I'll maybe read out the one from Richard Sanders. So in the long term, the idea is to have 3 regional hubs, each with a local relationship with a metrology lab. And then during the transition, presumably each local production facility will work with the US Metrology Lab. But after that, there will be need to cross comparisons between the different metrology labs, right? So that, of course, is another layer of challenges that probably needs to be accounted for already now as we're thinking about the designing the global system. How do you see the importance of these comparisons between the metrology labs that eventually will be providing certification, and then how do we set that up? Thank you.
That's a great question. I think, yeah, it's definitely necessary, and definitely at the BIPM level, this is the type of comparisons that we are often involved with. We conduct pilot studies and key comparisons, which is where the different NMIs will compare their measurement capabilities against each other. And it really does help you to kind of hone your measurement techniques to basically identify if there are any challenges in your systems. And so, you know, for a particular parameter, given good year and good timing, we will often do these comparisons about every 5 years. And so I imagine that if other metrology institutes are involved in this process, that we would basically have to come up with just some measurements that are required in order to solidify your, I think it's your calibration and measurement capabilities for these types of parameters for total alkalinity and for dissolved inorganic carbon. And maybe part of this process too is allowing some of the regional hubs that are providing values to participate in those level of comparisons. I think, I believe even at the BIPM level, if you have certain types of production laboratories, they can participate as a pilot study. So.
Thank you, Regina. Maribel, anything you would like to add here? Or?
So yeah, what Regina explained is kind of what metrology institutes are already engaging, and should be easy to have the same controls for the new production, well, new certification. And regarding the production, I think we still need to, in a way, create these protocols for testing the stability of the materials, the homogeneity, and all that. We don't need to create them from scratch, because the National Metrology Institutes that should be involved in the metrology hubs, the regional hubs, sorry, should be able to help the oceanography institution, the most likely will do the bottling, to do how to perform these other checks that have to be performed before the materials are sent to the Metrology Institutes for certification. So I think involving the metrology into the new model will help us to make sure that the materials produced in all the hubs are equally good, to say so, and reliable values should be achieved when you use the materials from any of the hubs.
Thank you. And I think, this challenge definitely requires an early and close establishment, establishment of a close relationship between the scientific community and the natural metrology labs. And, from IOCCP perspective, this is certainly a key priority for us to foster these dialogues early on, along with our partners. So we have a question from Libby Jewett about, she's saying that it's exciting that we're having this conversation internationally, and asking if Maribel could recap the timeline until the other two hubs beyond the US would be producing CRMs. And I know that there's nothing written in stone here, but Maribel, what do you reckon is the timeline, anticipated timeline or realistic timeline here?
Yeah, so that's a difficult question to answer, in terms that we still, if I'm not wrong, we don't have any institutions identified to start the process, and therefore the process hasn't been started in the other hubs. So seeing how long it will take for NIST that has already started the process to have their capabilities ready to certify values, that is at least around 5 years from now. So I expect to be at least maybe 10 years. So I hope this is not as long, and we kind of push forward all together and find it the volunteers to do this important work as soon as possible, and also have it as a priority, so it doesn't take forever to establish the new production and certification that we are presenting here. I also wanted to say that this is not written in stone, and we just discussed this in the spring meeting, and we came across with this new model that we thought was the easiest to create and implement. But of course, we also are open for suggestions if anyone else thinks that this is there is a easier or more feasible scheme for this.
Thank you, Maribel. Regina, anything you would like to add here? Or?
No, I think Maribel covered that.
Okay, great, thanks. So I noted there are 2 hands up, and apologies for keeping you waiting for maybe longer than I could. Let me just see. I think it was Stefan Zeitz. Would you like to maybe, if I could ask Katerina to unmute Stefan and let him say his question. Thank you.
Okay, can you hear me? Okay,
Yes, we can.
wonderful.
Yes.
Yeah, thank you very much for this very nice presentations, and I think this really thrilling and important issue. Yes, I'm Stefan Zeitz from the German National Metrology Institute, and I'm head of the electrochemical working group, and we are actually engaged in primary pH measurement. But I'm also the chair of the electrochemical working group at the BIPM that Regina has mentioned. And we have established this task group on seawater pH. Now, listening to all these contributions and questions in your presentations, I've become aware that maybe just thinking about the task group on seawater pH is a little bit small, and maybe we must think bigger. I wonder if it would be of interest for you or for the oceanographic community if we actually try to establish rather a task group on the carbon cycle at the CCQM. Okay, the CCQM is the consultative committee for the amount of substance that I would say most of the quantities fall under the umbrella of this consultative committee. Now, we have always been focused on pH because it's electrochemistry, but that's of course not all of them. Now, establishing such a task room is not that easy, and we have to go quite a long way to get there, but nevertheless, as mentioned, listening to the questions and to your contribution, it seems to be very important to me, because what you have asked for is more or less comparability for the measurements. And the BIPM is exactly the international organization on the primary metrology level who is responsible for that, as Regina has mentioned. And I think this could be a way where we could go to. I mean, I cannot promise that at the end there will be a task group, because there are many instances, of course, we have to agree to this and we have to approve this. But I think if we are able to make the need important and to demonstrate it, I think there is a good chance. So my actually simple question is if there is an interest to go this way.
I would say absolutely, because what we have experienced at NIST is that, you know, in order to tackle these measurement challenges, we need, I would say, cross-area collaboration. Notice that we need people with electrochemistry backgrounds. We also need people that are, I'm sure, involved in the gas analysis working group at the CCQM. And there's also the isotope ratio group. I feel like bringing together experts that are interested in looking at the totality of those types of measurements at the CCQM level would actually be very welcomed. And I think it's really needed for us to be able to establish traceability and consistency in these measurements over time.
Okay, so I would propose let's take the task group on pH, seawater pH, as a kind of starting point, and maybe we can level it up to some extent somehow. So we will put it on our agenda.
Thank you, Stefan. That will
Thank
be
you.
amazing and a great
It
help
would.
for this. Yes, thank you.
Thank you very much, Stefan, for this intervention. Also, a hand up I see there's from Urlis. I'm sorry, I'm not going to pronounce this right, Velogene. Would you like to say your question? Or maybe that was an... oh, yes.
Thank you very much. I have no question. Thank you.
Okay, so that must have been an accidentally raised hand. That's no problem. And I believe there was maybe... Okay, so I think we can proceed with the ones submitted with the Q&A. So Stefan mentioned pH. So maybe I would like us to move a little bit to some of the questions about pH reference materials here. And there's a question from Jan Ma. He's saying that different labs have produced purified MCP. And is there possible to organize an international comparison of pH indicator organist can give the purity evaluation for lab-made purified indicators. And maybe Regina, if you'd like to answer Jan's question. Thank you.
Yes, you're exactly right. I know that there was a study that came out maybe 2 years ago that shows that various labs that are producing purified metacresal purple are producing them at different levels of purity. And I think, you know, there is a need to assess the community ability to assess the purity and really just the pH determinations of these various batches that they are producing. So I would say, yes, for sure. I think that we should conduct a study to do comparisons on how do, you know, people assess purity, and maybe looking again at the purification methods. I would actually like to look at improving the purification methods, because I know that the current method is a little bit expensive in the fact that it uses a lot of acetonitrile. So I think definitely in pH, there are multiple ways that we can approach the how we can improve those measurements essentially. I know, I will say that out of our lab, Michael Fong is looking at a chemometric approach where he uses the full spectrum of metacresal purple to assess the purity of it. I know he's presenting that work at the upcoming Aquatic Sciences meeting, which I think is next week after next. And so also look forward to that, because we are thinking that maybe using the candidate reference material 8083, you would be able to build a chemometric model that will allow you to predict the purity of your purified dye if you don't really have access to HPLC.
Thank you, Regina. Maribel, anything to add from your side?
No, I think Regina is the expert here for the MCP, so I don't have anything else to add.
Great. So maybe a little bit following on around pH. There was a note, a question from Orange de Vomerbo, saying that, or he was wondering to what extent IOCCP, GOA-ON, and maybe other international organizations are collaborating with autonomous observing systems such as Argo. And he's saying that we're seeing an increasing number of platforms equipped with pH sensors and possibly soon PCO2. So, of course, you know, you've mentioned before in your presentations that we anticipate an increase requirement for or use for reference materials. The development and the expansion of the autonomous platforms and their capability for biogeochemical measurements is something, of course, to consider here. But I was also wondering to maybe expand on Oren's question is to what extent here we need to really also be mindful of the distinction you said, Maribel, about calibration of the data versus the actual use of reference materials in the observing systems across the different platforms. And I wanted to ask you maybe to comment on that a little bit. From my side, I'll just say that, of course, both GOA-ON and IOCCP are in close dialogue with all the coordinated observing networks, including the autonomous ones. So we always want to be open to hearing about their requirements for any coordinated actions, whether related to availability of reference materials or any other challenges.
So yeah, that's a really good question, because all these autonomous platforms also need calibration, and this calibration usually is performed against discrete samples that require the reference materials at the end as well. So I think when developing these big programs such as Argo and adding the BGC Argo package into it, I think we maybe need to push from maybe IOCCP or other institutions for them to include the actual need of reference materials also for their programs, even though their instruments don't need them directly, but they do need them indirectly for calibration purposes. So I think this is part of the issue that maybe the greater community outside of the chemical oceanographers that work in the discrete samples don't know the real need of reference materials, is because I think it's never highlighted in proposals, and maybe we need to start doing that now, about how much reference materials we use in each proposal that we put forward. I don't know if Regina, you want to add anything?
Yeah.
Thank you very much, Maribel. Yes, this is certainly a challenge we will try to take on in the near future. I just want to going back to the discussion we had with Stefan about expanding the working group focused around pH. I see some supporting or complementary comments here in the Q&A. Thorsten Kiefer, for example, is asking, would it be feasible to set up a joint hub that is distributed over 2 or 3 labs with complementary specializations and tasks in the production line? And noting that this could be relevant for a typical European setup. So I think yes, this idea would definitely be great to keep in our mind for developments. And then there's a question from Alison Myers, which I've been personally anticipating, about the growing community seeking to remove carbon dioxide from the ocean. Can we use a similar protocol to analyze seawater after experiments? And is there a lab willing to analyze seawater using this protocol? I think recognizing the huge vibe around marine carbon dioxide removal, we certainly need to do a better job in promoting the importance of using reference materials for this particular application. But yes, Maribel, Regina, if you could offer any responses with regard to Alison's query, please.
I would say for this, definitely that the same protocols would be used to analyze seawater before and after experiments. And I think this is also another reason, at least for us, why we also wanted to include some isotopic values on the materials. I would say in terms of, is there a lab willing to analyze seawater samples using the protocol, I would have to say basically, I guess, contact people that you know within the network that are able to run these types of samples. I think the labs that are involved in a lot of the global ocean observations are proficient in doing the measurements. I don't know if you're looking for someone to charge for the services, but it's the same process that we would be using essentially to assess CO2 removal from the ocean.
Yeah, I don't have anything to add. Yeah, the way that is, it was essentially what Regina said. The same measurements that we use to assess the inorganic carbon in the ocean are capable to assess the removal of CO2. And there have been few trials I'm aware of in Norway, with collaboration with European institutions to kind of decide which seawater measurements are the best to monitor, for example, for avoiding seepage of the, or locating seepages of the removed CO2. So I think that they are capable of doing that.
Thank you very much. Oh, there's a couple still more questions. There may be more detailed and specific. One from Nicholas Metzel. Do you have information, especially the report from the most recent international comparison, the ATCTPH, which was conducted in April 2017, and whether the conclusions are the same as Bachmann and Dixon 2015? So if I'm not mistaken, I think Maribel, you had a slide with some results from these intercomparisons, or maybe it was Regina. But if one of you could maybe help with any response to this question. Otherwise, we can also take it later after the webinar as well.
So I know that in my slide, I had just some of the values from, this was the 2015 study. I don't have any data from the April 2017 study though.
Me neither, but we have Andrew here if he wants to share anything.
Yes, Andrew, any chance you would like to maybe respond to this question, please? Please, Andrew, the floor is yours.
Thank you. Yes, we do have those results from that kind of got messed up in terms of the pandemic for writing about it. But the basic message of the 2015 is still true, which is that there is a significant variation in the capability of different laboratories, that there is still some potential suggestion that there is a difficulty in handling samples with high PCO2s, and also that on the whole, simplistically, the labs that do better are the labs that have the most experience. And those were all common in 2015, and they repeated again in 2017. There are some other minor suggestions that we could make about differences between methodologies, but again, it's mostly what I said there. It's difficult to really parse this out because we're not in every case certain that although people use the same equipment, they necessarily use it in the same way in terms of handling samples and calibration. But the most intriguing one is that the apparent existence of a problem dealing with high PCO2 samples is still clear and unidentified as to where that really comes from. Is it in the measurement process or purely in the sample handling? My own prejudice is that it's probably in the sample handling, though some of that sample handling is part of the measurement process.
Thank you very much, Andrew. So there's a couple of questions which I would say relate to the capacity to provide future support for researchers working in developing countries who might not have such an easy or immediate access to some of the facilities producing reference materials now in the US or maybe though in the future. So for example, Miguel Aristo is asking if for the Euro-African hub, are there any production centers already in mind, willing to become one? And I think Maribel, you've mentioned that right now the discussions are probably focused more on making the production center in Europe, while noticing the very strong demand for these reference materials in Africa. So this certainly needs to be taken into account on how to structure a production hub that would tailor to the needs of such a huge and a growing community of researchers as in Africa. We also have Urias Taylor from Liberia also voicing similar concerns about adequate funding and access to facilities for him. And also a very important question about I guess pertaining to communication and just being aware of the being updated about these regional hubs being developed. whether there will be Cia-Boluela Hankais, for example, asking will the hubs from these different centers apply for individually for different funds? How will it be possible for researchers to engage with these potential hubs? I think this is something that we need to take very seriously and maintain this communication with the global community, not necessarily just on an ad hoc basis from one webinar to another, but really think about how to keep everybody informed about the updates and developments in the different regions. So this is something I would maybe say from my side, but I'll ask Maribel and Regina to add any other comments on that particular aspect. Thank you.
So yeah, definitely we need to keep the conversation going on after or in between these big meetings. We in spring 2022 we discussed how we could do that best. We haven't come with a solution or a platform where we can engage and have all of us informed of what other laboratories are doing and the capabilities that they have. So I would just say maybe email IOCCP if you have any updates that we are not aware of, or also use our newsletter or mailing list to be informed. We also spread the word of many events and initiatives going on. But definitely we maybe need to do better in that sense if we want to create this new scheme in the hopefully near future. So we are open to suggestions if how we can do this engagement better than we are doing now.
Yes, and I just wanted to reiterate that communication is important. Since IOCCP helped to organize the workshop, the last workshop that we had, I think that they are definitely the best point for this international effort. It's definitely important for us, I think, to work together on developing these various hubs. I'm really excited that we have another location in the US that is looking to produce smaller batches. And I'm sure that as we move along, like whatever methods we're developing to work on the certification, like our process at NIST, as well as the process for the production centers, like we'd be willing to share the expertise. Because as we can see that we anticipate that the need for these materials will only grow. And so we need strong hubs that can help to support the demand for these materials.
Thank you very much, Regina. Thank you very much, Maribel. I think with these remarks, I would like to conclude our question and answer session today. I know that there are a few questions still unanswered, but we will follow up with them individually after the webinar. Yes, I also want to thank all I think we had 150 participants at the let's say the peak of the webinar today. So I think it's really great. It was wonderful to hear all your comments and questions, which will really enrich the discussions and planning going into the future. So I will finish here from my side and pass it back to Katerina to send us off for the last couple of minutes of this event. Thank you very much.
Thank you all so much. And thank you again to Maribel, Regina, and Artur for your amazing presentations. This has been something that the community has been very keen to hear about. And I'm sure you can tell by the amount of questions we have heard that this was definitely something that has been of great interest to everybody. So thank you again very, very much. I hope you can now see my screen. This is really, again, a slight technical issue. We have the contact details of the speakers up here again. And I would like to, again, thank them. Thank you all for joining. And I would like to point out that we have another GOA-ON webinar coming up next month on the 27th of June. The Latin American Ocean Acidification Network Laoka is going to be co-hosting the GOA-ON webinar. So please mark your calendars, and we will definitely be sending out more information about that closer to the time. And with that, I want to thank you again, everybody, and take care. We will be uploading this presentations, this whole webinar, to the GOA-ON YouTube channel. So please keep your eyes peeled for that. And I hope to see you around next month. Thank you very much again. Goodbye.